ladies and gentlemen, this is Salman Sheikh from Best Cloud Prep, and today we are going to look at AWS Lambda. So AWS Lambda is the ultimate abstraction layer. So you've got your data centers. Inside your data centers, you've got your hardware. Inside your hardware, you've got your assembly code and protocols. You think about your high-level languages, then you've got your operating systems that you're running. You then got your application layers as well as AWS APIs, and sitting on top of all that abstracted away is AWS Lambda. So basically, AWS handles all of these things for you. All you need to worry about is your code. So AWS Lambda is a compute service where you can upload your code and create Lambda functions. And AWS Lambda takes care of provisioning and managing the servers that you use to run the code. You don't have to worry about operating system patching, scaling, etc. All you do is worry about your code. You could use Lambda in the following ways. So you can use it as an event-driven compute service where AWS Lambda runs your code in response to events. And these events could be changes to data in Amazon S3 bucket or a DynamoDB bucket. Now these event-driven compute services are called triggers, and then you can also use it as a compute service to run your code in response to HTTP request using Amazon's API gateway or API calls made using the AWS SDKs. So what is Lambda? Well, let's say we've got a user. So here's our user, as you can see in the diagram, and they want to create a beam. So they then upload this beam to an S3 bucket, and that triggers a Lambda function. The Lambda function essentially will take that beam, and it will basically take the metadata as well, and it will put the words, for example, study for exam, over the beam. So that is how it creates a beam. And the cool thing about Lambda is that it can trigger other Lambda functions. So it can trigger another Lambda function to tell the user that here you go, here's your meme. So it will also trigger another Lambda function to store that meme back in an S3 bucket, as you can see from the arrows in the diagram. And finally, also you could use cross-region replication to store that meme somewhere else in the world. The other way Lambda works is as a compute function. So the previous one was event-driven, so this is just a compute function. So we've got a user, as you can see in the diagram. They send an HTTP request to API gateway, and then API gateway proxies that to Lambda, and then Lambda will run the code in response to that HTTP request, and then send it back to API gateway that will send it back to our user, as you can see in the diagram with the arrows. And the cool thing about the way Lambda scales is, let's say we've got two users with two separate HTTP requests. Both will hit API gateway and both will trigger the same Lambda function, but it will be separately run, as you can see in the diagram. So they will be separately isolated from each other. And of course, they will return a response back to the user. So Lambda is a bit different in order how autoscaling works. In autoscaling, in that, obviously when a user goes in, you might just spread it across web servers. You have 1 million users hitting your API gateway at once. That will then go and trigger 1 million different Lambda functions. So that's how well it scales. So one event, one function, or one request, one Lambda function. So remember this. So for exam's point of view, we really need to talk about traditional architecture versus serverless architecture, as you can see in the diagram. Because, this comes up a lot in your certified solution architect exam, associate level. So traditionally, as you can see, architectures in cloud has always been like this. So you send your request, it hits your Route 53, let's say, and then goes on to your Elastic Load Balancer. The load balancers send it to your web service, and then your web service might communicate with your backend RDS or database server, and then it sends back a response to the user. Now, that's a well and good, well-architected framework, but you're still relying on virtual machines. You're still relying on operating systems. Now, the cool thing about the serverless architecture is that basically you send a response to your API gateway that then sends a response to Lambda, and that can write to, for instance, DynamoDB server. So it could also write to Amazon Aurora or serverless Aurora, and then it will send the response back to the user. But like I said, if you've got 1 million users hitting your API gateway at once, and assuming you haven't throttled API gateway, it will scale to that instantly. You don't need to worry about auto-scaling groups or your EC2 instances becoming overwhelmed. So serverless architecture is a much better way of architecting your products. And in the exam, you're going to be asked different scenario questions. And essentially, what they're testing you on is how well do you understand serverless architecture. And so just to remember that you're always going to have an API gateway at the front, and that serves the front end. Then you're going to have a Lambda function behind it that scales out automatically. You don't have to worry about it. And then you are going to have, basically, if you're going to have serverless, then you want a database that is serverless. So either it's going to be DynamoDB or Aurora serverless. So, well, just quickly. So what languages does Lambda support? It supports Node.js, Java, Python, C#, Go, and PowerShell. And in terms of how Lambda is priced, it's priced on two different things. So it's priced on the number of requests. So the first 1 million requests are free, and then you are only paying 20 cents per 1 million requests thereafter. So as you can tell, it is quite cheap. So that's how much Lambda can save your company. And that's why you should always really look to go serverless. And then you also build on duration. So however long your function is running for, basically that's when it's going to build for. So let's say your function runs for 100 milliseconds, then you are going to be charged a certain amount. If it goes for 200 milliseconds or a minute or 10 minutes for instance, then you're going to be charged more and more. So you're charged on the number of requests and then the duration of those requests. So why is Lambda so cool? Well, you don't have to worry about any servers. You don't need system administrators. You don't need to worry about patching your operating system. You don't need to worry about antiviruses. You don't need to worry about why your EC2 instances keep crashing. You don't have to worry about servers at all. So it continuously scales. Like I said, every time you make an invocation to API gateway, that will trigger a separate Lambda function. And it's super cheap. So that's why it's so cool. And as I've said earlier, every time you deal with Alexa, every time you speak to Amazon Echo or Echo Dot, you are actually directly speaking to them. So it is really, when you think about it, you are speaking directly to AWS Cloud, and AWS Cloud is speaking back to you. So onto my exam tips. Just remember that Lambda scales out, not up, automatically. So if you have 5 invocations, it's going to scale out to 5 different Lambda functions being executed at the same time. So remember that Lambda functions are independent. So one event equals one function, remember that Lambda is serverless, and you should really remember this, understand this, what services are serverless. So RDS is not serverless, even though you don't have to worry about the operating system. Amazon takes care of it. There is still an operating system there that they have to go and patch. You still have downtime whenever Amazon is doing maintenance and stuff. The exception to that obviously is Aurora serverless. So RDS is not serverless, but there is an exception, that is Aurora serverless. That's the only RDS service that is serverless on things like DynamoDB. That is also serverless. Things like S3, things like Lambda, API Gateway, they are all serverless technologies. EC2 obviously is not serverless. It's a virtual machine, and they just remember that Lambda functions can trigger other Lambda functions. So one event can actually equal X number of functions. So if functions of triggering other functions, so you could have one event which triggers off 5 or 10, 15 or 20 different Lambda functions. So just remember this. And then just remember that architectures can start getting extremely complicated with AWS Lambda. So it can be really difficult to debug these, and that's why you need AWS SAAC service. It allows you to debug your serverless architecture. It also allows you to go in and debug what is happening in the Lambda itself. So we're not going to have a lecture on it, because literally all you need to know for AWS solution architecture is what it is. So it helps you debug your serverless implementation. And then Lambda can also do things globally, so you can use it to back up an S3 bucket, etc. And going into your exam, just know your triggers. So what can trigger a Lambda function and what can't trigger Lambda function. So for example, RDS cannot trigger Lambda function as of yet. So that is it, guys, for this lecture. Everyone, if you've got any questions, please let me know. If not, feel free to move on to the next lecture. And in the end, I would just like to acknowledge Gutenberg brothers from the Cloud Guru platform. If you have the time and funds, please visit their website and learn from the Guru of Cloud Guru. Thank you once again for your time, and we hope to see you in the next lecture. And if you like my video, please share, like, and subscribe.